Hello and welcome to the solutions to our Unit 6 unit exam dealing with statistics. Alright, so first off, in order to determine the mean mass of golf balls produced at a factory, sampling is done and the following statement is made. The mean mass is 45.0 plus or minus 0.47 grams. The results are accurate 19 times out of 20. So, the margin of error is that plus or minus 0.47, which makes numeric response 2 actually easier to evaluate. The maximum value is 45.47, because it is the mean plus the margin of error, that plus or minus bit. Is it possible that the mean mass of the golf balls is 44.52? Well, if we take our 45 and subtract that, we'll get a 44.53 as our lower limit. So is it possible? Yes. It is simply not likely. But the results are only accurate 18 times out of 20. So 2 times out of 20, it's not this number. We don't know if it's higher or lower, but lower is possible. Now, is it likely that the mean mass of the golf balls produced at the factory is 41.53? No, it is not. There's a 90% chance that it's in that 44. To get the 41.53, we take 41.53, subtract our 45 grams. It's a negative 3.47. We're talking about a z-score of negative 7.4. So there's a very low probability. So the minimum value of the confidence interval, yes, these are in a random order, is 45 minus 0.47. So that's a 44.53. And the confidence level is 90, since that's our 18 times out of 20. All right, so that solves really the first half of our test. Now, from data collected from forestry workers, the heights of trees in Jasper National Park are normally distributed. The mean is 4.5 with a standard deviation of 0.9. So what approximate percent is between 2.7 and 6.3 meters? So for this, we are going to go to our calculators. So let me pull that calculator screen up. And in this case, we are going to be looking at, first we open our distribution menu, and we want our normal CDF, since it's a continuous function. Now we're asking what percentage is between 2.7 and 6.3 meters. So our low is 2.7, and the upper limit is 6.3. They said the mean height is 4.5 with a standard deviation of 0.9. So we enter all of that into our calculator, and we've captured that here. And a second screen capture after processing, it's about 95%. So if we go back to that window, what approximate percent is 95? What percent is below 4.5 meters? So again, that's back to our normal CDF. This time we want the negative 1 times 10 to the 99 as our lower, and the upper limit is 4.5, because we want to know how many are below a given range. So we enter the upper limit as the lowest number we want, and the lower limit as the smallest number the calculator can handle, and it comes out at 50%, which makes sense because we're being asked what percentage of them are less than the mean. We want it to be 50%. What is the tree height 3 standard deviations below the mean? That's 4.5. minus 2.7. Since the standard deviation is 0.9, we multiply it by 3, we get 2.7. So here we have 1.8. So if 8,000 tree heights were measured, how many trees are expected to have heights between 1 standard deviation below and 1 standard deviation above the mean? So really what we're looking at is our distribution, our continuous distribution again. We want 1 standard deviation below so 4.5 minus 0.9 is a 3.6, and 1 above is a 5.4. So if we go back to our calculator display here, that's how we want to enter it. Lower limit is 3.6, upper is 5.4. We do that calculation. This 0.68 is the proportion of trees in that range. We multiply by the 8,000 trees we measure, and it's roughly 5,462. So there we go, 5,462. And if 8,000 trees were measured, how many are expected to have a height below that 4.5? Again, that's the 50th percentile that we've already done, so that's going to be exactly 4,000. All right. So a student in math received the following grades on 7 math exams. If the student needs an average of 80% for their final grade, what do they need to receive on the last unit exam? So these 8 numbers have to average out to 80%. Well, let's make a new whiteboard for the solution of this one. And sorry, it's a bit slow. So if we have 8 data points, it's supposed to be a 3 plus x to the 8 all over 8, and we want them to average to 80, then the one we don't know yet should be 8 times 80 minus all the others. That's 640 minus the other data points. So 640 minus 79, 89, 48, 89. This is a student that really needs to brush up on radicals before the final. 72, 64, and 99. So that's 640 minus 79 minus 89 minus 48 minus 89 minus 72 minus 64 minus 99. And the student has to do very, very well on that last test. Has to be exactly 100 in order to hit the desired 80%. This solves our Unit 6 unit exam.